Why is Python slow?
Typically.
And slow relative to what, I suppose, is another thing you have to ask. One of the things that you hear people say makes Python slow is the global interpreter lock, the GIL. What the heck is this, and why does it make Python slow?
Well, as of recently, it no longer exists.
Well, good.
Around the turn of the century, computers started getting more CPUs to do work at the same time. But there was 10 trillion lines of code that was written assuming that you had one thing going on at a time. And so the way that a lot of programming languages and systems and kernels dealt with this was by having a big lock. Like a big global lock. And whenever you needed one part of the system to communicate with a shared resource that they both have read-write access to, with another part of the system, then you would lock everything. And that's
Right,
what
so
that's
Python would let you create multiple threads to run on the multiple CPUs.
But in reality,
every time one of them goes like, open a new file, close a file, send a message to the other CPU, the whole thing would lock up.
Yep.
And so it would do the dangerous thing. And then it would unlock it and you'd go back to running. And in the end, most people discovered.
you just don't do multi-threaded programming with these languages.
Yeah, it was just too slow.
And there were workarounds that the language did and that libraries did for a long time. Whenever it did network I/O or file I/O or similar enough things like that, it had like escape hatches for these things that actually did let some things do a small subset of things and at the same time. But it was not great, and nobody liked it. And 20 years later, finally got the GIL out with a modest performance detriment to single-threaded code and speculative increases to more modern workloads. There's languages that do a lot of work up front, and then there's languages that don't do a lot of work up front. And they're kind of like loose and free with what kind of stuff they accept. Languages like JavaScript and Python and Perl, all the scripting languages, all the shell script, they just take what you give them up front and then they work with it, as time goes on. And there's languages that do a lot of work up front to like optimize your code, turn it into really efficient machine instructions. They have a lot of neat tricks.
I mean, so much of what people do with these programming languages is gluing together other things.
Exactly.
You pull this from your email and then you send it to the AI. The AI has to be fast. How often are some of these things happening?
There's different levels of communication between, communicating with different computers, the most expensive thing. And then like talking to some other program on the local computer is a little bit cheaper than that. And then if you still need something that's a little bit faster, you could like write a library for Python that's written in C or Rust or something.
You think talking to another computer is the slowest thing? I think you are unfamiliar with tape drives, my friend. That is the slowest thing. Severon says, Python is easy to use. It's what you prototype stuff with. Python is one of the most popular programming languages in the world, right? Yeah. So if you're like, oh man, I want to be a software developer, the quickest path, I think, is to master Python. Because people are paying for Python code, and it's easier than any of the other languages they're paying for. I have to admit, Python has become one of my go-to languages. Yeah. I need to write some little piece of code. I just start writing Python. Type in code, and I don't remember the command, so I take a guess, and it's right. 9 times out of 10, I guess, and it's right?
I think Python and Ruby are definitely languages that were written for people to read, for sure. And it excels at that. So who cares if it's a little bit slow?
So Python, for instance, has lots of functions. You can give it a string or an integer or whatever, and it just kind of does the right thing. All that's work that has to be done to handle the different cases, whereas something like Java is strongly typed. Every function takes an exact type, and you must pass it to it. And a lot of times you have to put in parentheses the type it's looking for before the thing to prove to it that you're passing it the right type, which annoys a lot of people.
For example, if you write a function in Python that takes 2 arguments and adds them together, then when you call that function, you have to first check that it's a function. Let me make sure that this is really a function. It takes 2 arguments, and then you gotta make sure it takes actually 2 arguments. And then you gotta make sure that you can actually add them together. Maybe there's like nothing that can do the plus thing. In C, it's like 1 assembly instruction and a function call. That's it.
The programmer must have things perfectly set up for that one instruction.
Yeah, but in Python, it's like, well, does it look like it can
type
add
away
together?
It works away, yeah.
Rust.
What about Rust?
What about Rust? Rust is a good one. I think it's very different from Python. It's very promising. There's things that Rust does really well. It's not the language of the next 100 years, but it might be the language of the next 10. Languages, they can and should evolve. And I think that Rust is the natural evolution of what we used to use C for, but we didn't really want to get up with like ADA and formal verification. pretty good. You can do a lot of great stuff with Rust. You can do a lot of great stuff with a lot of languages.
Is Python interpreted language, not a pre-compiled language?
Yeah, it's an interpreted language. There are variants of Python that have a compiler for a subset of the language. Like Mojo is a good example of that. And there's a Python JIT interpreter, which is kind of like...
Just-in-time compiler.
Yeah, so it's kind of a bridge between interpreted languages and compiled languages where you want some of the benefits of an optimizing compiler, but you don't want to spend the time doing that before you can actually run the thing.
Do you guys use Python in Speedify?
Not in the Speedify app. Probably our biggest Python project. Maybe DevOps stuff, maybe the town, one of the two. But we have a big, virtual town that we use to test Speedify. It emulates the relationship between a client and a server, multiple clients and multiple servers, clients talking to each other. So it sets up these virtual networks and rules for how they communicate with each other, network emulation stuff. All that's Python.
And all prototype stuff, right? The streaming stuff, the stats about your live streams, I first wrote in Python. And once I showed it was as a separate thing, you ran next to Speedify. Once I showed it was right, then we said, okay, let's really do this. And there's none of my Python in there. So Brian Purdell, our Chief Technical Officer, says the biggest Python thing we have has to be the automated tests. We have so many tests written in Python that run every single night, actually every single day, right? We have a bunch of huge computers in Montreal for some reason. I have no idea why. That are just, whenever somebody makes a change to Speedify, the Python code grabs the latest version of Speedify and tries everything. Huge amounts of code, high-speed connections, low-speed connections, unreliable connections, lots of connections, one connection, no connection, logging in, logging out. All this stuff written in Python over and over and over. Different topic here. What are future plans for Speedify? Right now, a lot of our attention is on making sure Speedify works great on routers. This 16 release comes with the performance enhancing proxy. It comes with the load balancer. So we're really working on improving performance. So this is the Miri X510. It's really for video professionals. It has a 5G modem. It has a 4G modem. So 2 real cellular. It's not just dual SIM. You put in 2 cards that uses one at a time. It's got 2 full radios. It's got Wi-Fi 6, 2 USB ports on the front. You can hang cell phones or additional cellular modems off them. Uses NPF batteries. It's got 2 battery slots and only needs 1 to run, so you can swap batteries all day. We're not Miri. We're partners with Miri. They're a company in Pennsylvania.
We're doing a collab.
Yeah, that's right. We're also making sure that travel routers, GLINet, Barrel AX, and they advertise it as being able to do WireGuard at up to 300 megabits. We can do 6. We can do 600 megabits.
For however great Python might be.
We did not get to those speeds by adding Python code to this. So what is coming for 2026? Anything big we can look forward to? 2026, that's so far away. We're agile, man. I mean, I don't know for 2026.
We're putting Speedify on your toaster.
Self-hosted servers are coming. They're going to be out before 2026, I promise you that. Lots of improvements for routers, but that kind of probably takes us to the end of the year.
With all the holidays, probably. Yeah.
With all the holidays, probably takes as long as that. So continuing to work on that. I think a lot of analytics stuff. If you looked at myspeedify.com now, next to your devices, there's a little graph. You can go click and you can get some analytics. We have a little bit of data of what your devices did on the network in the last 2 weeks that we can graph for you. So that's a kind of cool feature. Current version of Speedify 16.03. You should update if you didn't. Probably be another update next week. More improvements for routers. Neat things getting slid in. I think a few more of our networking features will be more configurable, like the bypass is. So thanks, Will. Thank you to everybody who commented and asked questions. This has been a lot of fun, and I'll see you all online.